Hey, what's up? I hope you're having a good morning. It is 4:02 in the AM here in South Carolina. In this video, in this video tutorial, I'm going to show you how to create a linear regression algorithm, and the project we're going to be building is a project that's going to determine the crop yield for based on the data given. What will the linear regression algorithm determine what our crop yield will be? And for those of you who do not know, a linear regression is a machine learning algorithm. And we use this algorithm for predicting the relationship between a dependent variable and one or more independent variables. And it's done by finding the best fitting straight line to make predictions based on the given data. So it uses the data that we give, and with that data, it determines what the outcome will be. So we're going to be doing this in Python. We will be using Visual Studio Code Editor. So let's begin. First things first, you're going to create a new folder. In this folder, we'll just name it Crop Project. On Visual Code Studio, and where's it at? We're going to select that folder, click on Desktop, click on Crop Project, then you're going to select the folder. Once you do that, we're going to hit New File, and we could just name this file crop prediction.py. Now that we have the Python file created, we are now going to start importing or pip installing some of our libraries we're going to use. So first things first, we're going to pip install pandas. We're then going to pip install skylearn or sklearn. Great. Now that we have that done, we can start writing our code. First things first, we're going to import the libraries that we pipped installed. So we're going to say import pandas as PD, import numpy as np from sklearn.model underscore selection, import train underscore test underscore split, and from sklearn.linear underscore model import linear regression. Last, we will import matplotlib. This will take the data from the algorithm and make a visual application interface where we can see the result. Import matplotlib.py plot as plt. Now we will move on to our next part of the next section of our program. We're now going to generate the data for the demonstration. So what we're going to do is we're going to first create a comment explaining what the source code will be, so we have notes, so when we go back into the program at a later date and time, we understand what each part of the program does. So this will generate random data for demonstration. So we're going to say np.random.seed42. We're going to say num underscore samples equals 100. Then we will say data. Now we're going to say data equals, and we're going to create our dictionary now with the key values. So we're going to say first one's going to be temperature. dot random dot uniform. And I'll say rainfall. Np dot random dot uniform. Soil nutrition or nutrients. Say np dot random uniform 0 1 1 samples. And last but not least, we are going to do crop yield. Okay. See, crop yield, np.random uniform. Okay. Also, just it's always good to save recent or save frequently to make sure that the information you're giving or typing doesn't get lost. Now that we have that done, we're going to create our data frame from the random data. So we're going to create another comment. We're going to say this will create a data frame from the random data. I don't know why this is still red. 1 second. Let's take a look at this. Forgot the comma right there. Okay, there we go. So df equals ed.data frame data. All that information is now going to be placed into a data frame. We will now go to our next line of code where we will now take the data, we're going to split it. We're going to have one section for features, one section for target. The features will be the x-axis and the target will be the y-axis. So we'll make a quick comment. This split will place, okay, let's figure out this. This will split the data into features x and target y. We're going to say x equals df. df stands for data frame. Temperature, rainfall. Make sure you put these strings in between quotation marks. Soil underscore nutrients. X, we will do the y-axis. Y equals data frame crop underscore yield. Now we will move on to the next section of code where we will split the data into training and testing sets. So we'll say, whoops, this will split the data into training and testing sets. So we'll say x underscore train, x underscore test, y, whoops, y underscore train, y underscore test equals train underscore test underscore split x y test size equals 0.2 random state equals 42. Now the next set of code that we're going to do is going to create the linear regression model, and it's going to train it as well. So we'll say this will create and train the linear regression model. So we're going to say model equals linear, sorry, I'm not pronouncing that right. Regression model dot fit x underscore train, comma y underscore train. Now the next section of our code, it will get the coefficients and the intercepts of the model. So we'll say this will get the coefficients and intercept of the model. So we will say coefficients equal model dot coef underscore. We'll say intercept equals model dot intercept underscore. Now we will print the coefficients and print the intercepts. Coefficients oops, don't forget that comma. Print intercept. And this will now, the next part of our code will predict the crop yield for the test set. So we'll say this will predict the crop yield for our test. So we will say y underscore equals model dot predict x underscore test. And now that we have that all, now we have all the information in the program. We have our objects prepared. We will now, the last section of our code will make everything that we put into the program to become visual, where the user will be able to see it. So we're going to type right here, we're going to say this will create the visualization to compare actual versus predicted crop yield. So we're going to say plt dot scatter y underscore test y underscore predict. PRED stands for predict. PLTX label. I'm going to say actual crop yield. Say plt.y label. Predicted crop yield. We'll say plt.title. PLT title. Actual versus predicted crop yield. Then we'll put PLT show to show everything. Now let's see if our program will run. File save. You can go down here in the terminal and hit clear. This will just clear the terminal screen to get some of that clutter out the way. Okay, let's look at line 44. It says, for those of you who don't know, this is your terminal. The terminal pretty much tells you, for example, if there's a syntax error, it will let you know in the terminal. And that's what we're getting right now. It's saying that I did not put on line 44. As you can see, I put an E there instead of the T. So we're going to get rid of that. Hit File, Save. Go down here in our terminal, hit Clear. And we're going to hit the Run button again. And there you go. We have our actual crop yield, the title. We have our predicted crop yield. And then all these different dots is comparing the predicted crop yield from the actual crop yield. So congratulations on making your first algorithm, your first linear regression algorithm. If you have any questions or concerns, please feel free to reach out. Feel free to leave a comment. If I offered any value to you today, I ask you to like my video, subscribe, share this video, and thank you for your time.